Alright, it should be recording. So I deal with some comments by the cowboy and friends, and I delete them but save them, and it's going to be the policy. I don't have an obligation to indulge in to facilitate trolling, and that's all this account amounts to. So anyway, the last two videos have raised a ton of points about the weakness of conventional physics, its explanations. They have no response to any of that. No links to any of the great evidence, the brilliant insights, anything. Nothing. And all they have is these little nitpicks. Because, I'm providing so many details, they can sit there and find little problems with some detail I've provided, where I've made some mistake. And so they put up nothing to be scrutinized, and they just go to the critics table and start criticizing when they've never. It's like it's like an art critic, somebody who can't paint, judging the paintings. It's just horseshit. The can't doers critiquing the doers, just horseshit. Again, no balls. Like I said, it was crime enough that this frickin' flaming vagina would sit there and take John Wayne's name. That was enough of an offense to block somebody right there. But anyway, you said that an electron is composed of other black matter bits. I said I don't care. I've said it could be absolutely nothing, could be a something, could be full of bits, could be any choice of your preference. The point is it obviously absorbs energy, and it uses it in the sense that it moves. So in that sense, yes, it has to be full of something, or it couldn't absorb anything. Duh. So yes, you could probably think of it as it starts its life off with nothing, and then it collects. And as I said in the video, I said it literally. I said you can just think of it as it can hold a certain number on its surface, or inside, however it works. A certain amount of momentum, a certain amount of fish moving in a direction. It ties a string to them. And if one fish is going this way, and one fish is going that way, and one fish is going that way, or dogs, or cats, you can think of it as anything. And in the end, if it's not moving, it's because it has a string to a fish going in every direction equally. So it's balanced. And how it gets unbalanced is it gets more dogs going that way than are going that way. Now that's not a complex concept. Right? You should be able to grasp that without too much trouble. And a black on black bounce can only happen in 180 degrees according to you. Well, yeah, it's according to me in the sense of that's what I've said. But, in thinking about it, this is stuff I pointed out the other day that, yes, I wanted to kind of redo the description with this idea of like the Velcro idea, the idea that the force hits it and kind of stays for a while, and it's just about how long it stays in something. That's really all this conversation is about. How long it takes for something to give back the force it absorbs. How long it sticks. And so in that vein, I was thinking about the electron, let's say. Where's the other camera? It should be right here, convenient. There it is. This is, so I would argue that the electrons, as I've kind of stated, there's always some sort of, an electron always has to find a comfortable place to live. That's what charged particles have to do. They have to find a place where the charge is comfortable, where there's no, they're not going to stay in a place unless that place has an equal amount of pressure from all directions. That's just the rule of being a charged particle. And so the idea would be is that the other electrons there's energy holding it in place. Now for a hydrogen atom, that energy might be in the form of another electron on the opposite side, and it just might be proximity, because it's much smaller. The electron avoids each other just because they have to hide behind the proton in the middle. But for the sake of argument, I'm just going to use this example of the tension between electrons. And So the point would be is that a force comes in and it would hit the electron. The electron would absorb it temporarily and move. Try to move, we could even say. And depending on the metal, depending on what it's hitting, it either can or cannot based on how much pressure is already in these electrons. So if there's a lot of pressure, then the pressure will be transferred to the other electrons and they'll move in this direction or in this direction. And that might be what you'd call electricity. So the electric current will move in a direction, and that would be the right-hand rule, technically. There's a reason it goes this way instead of that way, and I don't have that at the moment, but it seems like, yeah, you just have to figure it out why it's that way. So either the electron actually changes its position, or it transfers this push, gets transferred to this electron. Now that can happen in stages, right? We're talking about something that's happening at the speed of light on a scale that's infinitesimally small. So, you know, the amount of interactions that can happen in what we consider 1 second is like 1 billion years to them. To these little bits, they're going through 1 billion years of experiences. It's happening so fast. But the point would be is that the electron moves, and at some point either the energy is transferred and it becomes electricity, or the energy is somehow in some way, it can't go this way and it can't go that way, and it ends up leaving as infrared, as heat. Okay, so that's the other form, right? So we have either it turns into electricity, or it turns into heat, infrared radiation, a lower frequency, and probably more bits at a lower frequency, or it's reflected. And those are your choices. And my argument is the reflection is just basically this pressure of these electrons, okay, preventing this from going in, and so it pushes it back out, and the process of adding force this way means this little bit, this little photon bit, this little quanta gets ejected this way. So we're just back to the point that you just think of it as Velcro. So if it's Velcro, it sticks. Alright, now if it stays, then that means it moves, that means it pushes this way, that means it's electricity, right? And then heat would just be the bit flies off, but now it's going to be leaving at a lesser frequency. It's just going to be a bit. I mean, heat is basically being caused by just bits, extra bits. When it finally irradiates out of an object, it's in the form of infrared radiation, but what form it's in when it's in the atom, who knows? But regardless, this is the basic idea is it's just a transfer of the piece of momentum. The momentum goes in, it's quantized, that's all consistent with quantum mechanics underlying fundamental philosophy, that there's energy conservation, and then the energy is in the form of these quantas, these little bits of energy. So in a sense, this explanation is perfectly consistent with that, and it can be understood that, yes, this whole system is under pressure, and you either move the pressure through the wire as electricity, or you give back the pressure in the form of heat, or you give back the pressure in the form of another photon, a reflection. So that's not too hard to follow, is it? As a basic concept, is that just too much for you? Apparently, you just want an answer like virtual photon. There. See, they can just say virtual photon, and they pretend they explained all of this. They explained electricity, heat, and reflection by just saying virtual photon and magnetism. They no work at all. So I guess the point I was trying to make is, in response to this 180 degrees, I mean, obviously, something happening from two directions at these angles would result in the same energy as this forward motion. So it would release a bit that direction. So in that sense, it makes sense. So maybe it can be, if two things hit the electron at the same time, you'll end up with a photon created in the adding those vectors. And that would be consistent with, say, a Feynman diagram. Alright. Text. Hello? Where did it go? Oh, there it is. Alright. Alright, according to... Okay. That means the black bit can't stick or keep up with the electron. See, I don't see how that follows at all. So let's just separate that. I could argue that all of this stuff that happens that creates electricity and magnetism, well, parts of magnetism, obviously the negative part, the North Pole part of magnetism. Well, let's just say electricity and visible light, or the electromagnetic spectrum. That's all electron energy. It all has to do with affecting electrons. So we don't need to mess around with a conversation about anything other than the black bits for the sake of this conversation. And let's just say the red bits aren't really relevant, because in an electron, the only thing an electron is going to do with the red bit is it's going to exchange a red bit going this way for a red bit going some other way. Theoretically. Right? Yeah, I think that's the point. It exchanges the one that it possesses. Okay, so an external bit hits an internal bit. The one that's held, changes from going... Oh, that's not right either. Alright, so we'll come back to that one later. Yeah, there has to be the change in direction has to be between something that's not in the electron. So it's just facilitating a transfer between... Well, I'll pause. Yeah, that's what I'll do. Yeah, clever. Right, why didn't I think of that? Alright, I think I'm back. Alright, so in the electrons, and so when an electron is moving, technically the red interaction doesn't have any meaning to the moving electron, because all that the red interaction will do is it will provide an opportunity for energy, okay, that is going to interact. Red energy would interact with the electron, and what it's going to provide is an opportunity for something, the opposite, okay, a piece of black. The two will interact, so black energy and red energy will interact, and the red will leave going in the direction of the black energy, and the black will leave going in the direction of the red. So it just transfers the momentum. So the object, the electron itself, doesn't keep any momentum. It doesn't gain any or lose any. It's just purely facilitates an interaction. And so the same thing is true of the proton. So the proton, in just the opposite manner, takes does exactly the same thing. It takes a piece of free energy that comes in and allows for two bits of energy to interact and exchange their directions. So the red bit leaves and the black bit leaves. And there's no momentum interaction. So those are the two interactions. You get hit by something the same color as you, alright, and the force sticks until some other force unsticks it. So the kinetic reaction is something hits something, it sticks to it, the momentum is spread over the whole of both masses until some other force hits it, and then the little bit of the mass can pop back off again. So in a sense it's a kinetic ball experiment, but with big things and very, very small things. And the difference is when it hits, because it's so big, it doesn't bounce off and it doesn't make the other thing move away. It just sticks to it and moves with it. That's the physics of it. And so there's two kinds of interactions. There's the momentum that's gained when something sticks to you, when the same force hits you, and then when the different force hits you, the only thing that can happen is some other bit of force that's free that might have interacted with you will now be deflected. That's the way it works fundamentally. Alright, so back to the crap. Yeah, the crap. Alright, this means the black bit can't stick or keep up with the electron. No, it sticks, it gets absorbed, however you want to word it. Again, I'm just trying to give you a visual model. So in my opinion, the way to think about it is if it's the same color as you, it sticks to you until you hit something going the opposite way that unsticks it, or has opposite momentum. So until something having enough opposite momentum hits you, it sticks. No matter where it is within it, because it can only be influenced by 180 degrees by the matter bits of the electron. So again, I'm saying that I'm not sure if it can only be 180 degrees. I mean, obviously if two things hit something, there's twice as much energy, right? That's logical. So if one thing hits it this way, and then two things hit it this way, the idea would be is that it has two bits of energy going this new direction. So it not only decelerates the first, the one that's stuck, it's not only stopping it, that is throwing it back, it's giving another piece of energy which actually moves the electron. So, in the scenario described, alright, so I have to be in the yeah, I have to have blank paper here in the right area, and this thing can't be in the way. We could do this maybe. Maybe that'll work. I don't know. Yeah, it seems like looks like it's in the way. So hell with that. Still working on performance issues here, so sorry. So what was I going to say? Okay, so step one, okay, is little bit hits the electron. Right? Step two, the electron and the little bit was going this way. Now go this way. Step three, okay, little bit going this way and little bit going this way are heading for electron and little bit. Right? Get that? So now you have these two coming at it. Okay, now those two hit it, and you end up with a little bit leaving this way, the electron moving this way. This one was the electron moving this way. 1 bit worth. Now the electron, because it got hit by these two that are sticking, now it, okay, the electron moves and the little bit left. 1, 2, 3, 4. Get it? I don't think that's insanely complicated. I guess I gotta figure out a better way to do this apparently. Anyway, because it can only be influenced by 180 degrees by the matter bits of the electron. Okay, so I've answered that. Alright, then he does this one sentence thing. That contradicts your point that the electron would stick or keep up. There's no contradiction, so you can see, this is the problem with your language. You make too many accusations. I mean, this is one of your more polite comments, and it's full of accusations. And that's just rude. I mean, you really, I don't have any expectation I could type this way to other people, and they'd say, "Oh, gee, what an interesting comment." You have to have some kind of civil skills, asshole. All right, you never seem to be able to stick. See, this is the kind of crap. Just I have no reason to accept this shit from you. You don't know me from shit, fella, And I certainly don't know who the fuck you are. And why should I take this shit from you? I wouldn't take it from anyone else. Why would I take it from you? I wouldn't take this from an uncle. You never seem to be able to stick to your own 4 simple rules that you adore so much. So it's kind of a silly statement. Okay, so you just make vacuous, non-existent defenses of the silly notions you love so much. Your little bent space and your little special frames and your little wooey space and then your little virtual photonies, right? I can ridicule your shit just as easy. So why don't you man up and we'll do a live debate. Rhetoric just full of a bunch of insults. If that's what you want to do, but just have the balls to do it. Let me insult you right to your face too, fuckface. God damn. Probably because you're too stupid to pay attention. Just useless garbage. Yeah, I'm not as stupid. I mean, I obviously don't have to pay attention when somebody just says, the geometry makes it happen. There is no mechanism. Yeah, I don't have to pay any attention to that. Virtual photon, that just does it. It just magically makes attraction, magically makes repulsion. No mechanism, no drawing. Show me Feynman's drawing of how magnetism works. Show it to me. I bet I don't need to pay any attention at all to understand it. Yeah, because it's vacuous. There's nothing to it. As it is apparent from your abhorrent literacy skills. Well, so literacy is really important to physics. I've heard that all the time, that, if you can't spell good, oh yeah, you gotta be a horrible physicist. I mean, it really has to be emphasized. You can't even stick to your own 4 basic rules. Oh, so you just said the same thing again. And you are expected to summarize all of the other theories. What's to summarize? Again, I play their quotes. I play them saying stupid things like, well, you cover one of the slits and the light's just blob. I play them saying stupid, idiotic things that are just fundamentally untrue. And then I point out how, like in the case of radar jamming, that there is such a concept, that this idea is you can't receive 2 stations at the same time, especially when they're out of phase. It's hard enough to do it when they're in phase. If you could actually get 2 carriers to be perfectly in phase, but playing 2 different stations, well, you'd get a lot of noise. But you'd get something. But if they're out of phase, you have no hope of tuning anything in. And you can't figure out that, oh yeah, that might be the simple explanation. And then we don't have to have this idiotic notion that photons interact with other photons. It's bad enough you have an idiotic notion of a wave function and invisitons interfering with each other, but it was even dumber when you said, oh yeah, well, regular photons do it too, even though there's no experiment demonstrating it. So again, I don't get to interrogate you on the nonsense you believe in. Anyway, moving on. Let's see, start at the beginning of this piece of crap. You keep saying no experiment disproves you. I say there's my theory is perfectly consistent with the evidence, and that makes it a damn good theory, fuckface. And it's 100 times, well, at least 98 times more details provided. And that you answered everything. Yes, it answers all the big questions, and answers them really well. Let's go back to the lunar laser ranging experiment then. You're not going to win that argument, which you failed to answer. Let's see, that's a lie. That's another lie. Your comments are just full of crap. It's just a lie. I mean, I spend this much time on these subjects, and assholes will say I didn't answer it. How did I not answer it? I spent 20 minutes, 30 minutes talking about it, and just closed and picked your conclusion and disregarded the rest. There's nothing to talk about. I went into detail about how the laser goes to the moon, how it diverges in a gigantic amount, that only less than 1%, less than one in a million of the photons actually hit the reflector, and they only get back 3 or 4 or 5 photons out of the billions they sent. So what conversation is there to have? That's not exactly what you'd call an experiment that shows the Earth is moving, idiot. That doesn't explain too much. It's for one purpose. It just gives you a distance measurement, and the distance measurement is essentially a verification of the speed of light. Alright, not only does it show that the moon takes a non-Newtonian orbit, so where was this proof written? Around the Earth, and your precious inverse square law is slightly off. Where do you have evidence of that? So why don't you cite some evidence for that? This non-Newtonian orbit. What kind of orbit do you think it is? Hassan Pfeffer? Jerkin-Jocker? Herbert John Wayne? Is it a John Wayne orbit? I mean, who's the theorist who has the new orbit standard? What is a non-Newtonian orbit? Whose orbit is it then? If it's not Newtonian, then it's not Einstein either. So whose orbit is it? But whether the photons are emitted with respect to an absolute frame or with respect to the Earth's velocity makes a difference of about 30 kilometers. So just more horse shit. Photons move. So you think the light coming from the sun, we see the sun exactly where it is. Or the light from Venus, we see Venus where it is right now. We're not looking at it where it was, we're seeing it where it is. You still think so. See, I don't get to ask you any of these questions, get your answers. How big an idiot are you? Let's find out how big of an idiot you are by asking a few questions and having you answer them for a change. As the Earth moves at 30 kilometers around the sun, even though obviously it doesn't move 30 kilometers, 30,000. Even though the spot on the moon is only 2 kilometers. I don't even know how big it is, but yes, go ahead. It's big. Okay. This means it actually matters how it is emitted if you want to aim your laser. It doesn't matter because the reflector reflects everything directly back to the source. So, as I pointed out before, the photon that hits the reflector isn't the photon that hit the mountain. It isn't the photon that hit the valley over there. The only photons that come back are the ones that hit the reflector. Okay, so those went in a straight line to the reflector and a straight line back. That's it. So you don't have to worry about any of this other horse shit about angle differences. Because no matter whether your circle is here and your reflector is on the edge of the circle, or whether your reflector is on this edge of the circle or your reflector is in the middle, it's still going to be a straight line for those photons. Dumbass. This means actually matters how it is emitted if you want to aim your laser. The conclusion that the speed of light is constant relies on relativistic conclusions. No, it relies on the preponderance of the evidence. You don't have a single instance of any kind of real data demonstrating a circumstance where the speed of light isn't consistent. You have no evidence, essentially. Zero of anything else. And in terms of any kind of good evidence. I mean, you have convoluted, I'm going to make some kind of weird argument that the light curved or the light did some kind of weird bendy thing, like it went this way and then it hooked back and hit the reflector and then came back this way. I don't know. Some kind of horse shit, some sort of dodge, some sort of convoluted, bizarre evidence, but you don't have any evidence of this light isn't consistent because the Earth-Moon system is in motion. So what? You have a time of flight procession as the moon orbits otherwise, and it doesn't matter. It's not going to change anything about the path the photons take. The photons obviously, when they left the laser, they weren't heading exactly for where the reflector is. They were heading for the location where the reflector will be when they get there. So they traveled a dead straight line because they were aimed a little bit ahead. But of course you deny basic kinematics when it doesn't serve you well. Which is this, I'm not denying kinematics because I believe in the constancy of the speed of light and I understand that photons travel straight lines. So that's just horse shit. This denial word is horse shit. If anybody uses it in a comment, I'm blocking you. You use the word deny, or you use the word it's already been explained. The phrase it's already been explained to you. Any of those things, and you're going to be in big fucking trouble. You haven't answered any of that kind of crap. But yeah, that one's just out. Okay, this deny shit. Alright, what's amazing is all this is, let's just make sure I got the rest of that one. No, okay, yeah, we read that whole piece of shit. Yeah. Let's not do it again, Gary. What's amazing in all of this is that even some of your own fans that have a couple of brain cells to think independently can see you're full of shit. Whatever this is. So again, just point me to these fans. Point me to these people who have an argument. Now, anybody can claim I'm an asshole. Anybody can claim I'm full of shit. But do any of them have an argument they can actually make? And so you have to ban them. Again, I only ban people because they're unnecessarily rude and they don't even try. You know, like, just look, when I posted on that message board, was I me? Or did I hold back a lot? I was, you know, I didn't say what I wanted to say. I said what I had to say. You know, to be able to engage them. I couldn't just call them what they were, pretentious little putzes. So, you know, you don't know how to play a rational game. It's not my fault. You can't play the game. You don't have the disposition for it. You can't moderate your offensiveness. That's your problem, not mine. You're the guest here, jackass. Alright, for pointing out the truth. Yes, sorry. The truth based on no facts. Oh, thank you. Sorry, Gary, but the truth is insulting. You really did dismiss the simulation as using their math and ignored it. So this is Johnny Wayne defending whoever the other creep is. No, I pointed out exactly, I made exactly the same argument, so you're going to lose this argument too. You want to just play my whole video where I was talking about it? Because I made the argument that you're just counting the mechanism that throws and receives. That's part of the redshift. The fact that my ear is moving means it's receiving, okay? Motion is part of the receiving process when I'm redshifting the sound. If I don't move, the mechanism of my ear doesn't move, then it can't redshift it. So obviously making static balls that things just hit doesn't account for what really happens in the process of redshift, which is my ear moves. Anyway. Wow. A basic argument explaining why what you said in reply to the other comment it violated your own basic rules of your theory and you deleted that comment. Yeah, I deleted it because it's rude, okay? So, asshole. And that was made obvious. So, you know, and I've already set the terms. I'm not leaving crap on my message board. I'm not going to type a response to this cunt. So I'm not leaving his accusations there. You're not free to make... If you just don't understand how you can't just walk up to somebody and start making accusations without them saying, fuck you, then you're just too stupid. So much for answering everything. Well, again, I am answering it. So again, just another horseshit example. So much for... Well, so much for you, fuckhead. I saved the comments, and I'm responding to them. So fuck you. You are a real scumbag. No, you're the anonymous coward. You have no icon. You have no data on your website, on your page. You have absolutely nothing. You're a fucking troll, scum shit. You have no right to point a finger at anybody. And so we post a link to a copy of the post that I deleted, that I already have a copy of. Thank you very much. I mean, I have them in my, you know, I put them in my little tool, so I, you know, see this little thing here? You know, see, I saved them all right there. Anyway. Some of your own... Okay, so now this should be the last one here. So you're saying that the sound Doppler effect is systematic with respect to the source... Symmetric, okay. The source receiver. I'm saying that, yes, just as Professor Lewin is saying, He's saying it's symmetric with electromagnetic radiation. He says it's asymmetric in audio sound. Alright? I'm saying, no, it's symmetric in both. Completely symmetric. And again, the animation doesn't make a distinction between sound, audio sound, or electromagnetic radiation. The simulation doesn't say this is a simulation of audio sound in an atmosphere, or this is a simulation of electromagnetic radiation. So again, the simulation is disagreeing with Professor Lewin. You know, in the sense that if it's a simulation of electromagnetic radiation, Professor Lewin would disagree. Okay, are you saying all Doppler effects are symmetric? Yes, I'm saying it can't possibly matter whether you move away from something or the something moves away from you. It just can't matter. Alright. It just can't. Okay. You haven't made it that clear at all. Yeah, I did. So that's just another lie. Man, you people just lie, lie, lie. I can probably point to at least 7 points in the video where I say it explicitly that it can't matter. It can't matter. I can probably find those exact words 7 times in the video. What a liar you are. Because you keep switching your example. There's no... What's the difference? Yeah, I switch from cats to dogs to goldfish. Yeah, I can switch the metaphors. How does that make it more complicated? That's supposed to make it easier for you to understand. So I can say things, well, it's like catching eggs, and you got to catch. I can say, well, no, it's like catching cannonballs. Can you imagine if you didn't move with the cannonball, what a mess it would make out of you? I mean, what was so hard to figure out? Can you ever stay on topic? So amazing. So because I used 2 different metaphors, water hoses, flashlights, and eggs, 3 different ones. So to point out that that's where the energy transfer is different. Catching the egg, when you have to catch the egg, see if I'm moving backwards, I don't have to do as much work catching the egg. If I'm not moving backwards, then I have to do more work to catch the egg. I have to put more energy into the equation. And that's the difference. The energy is in the form of me taking a faster velocity relative to me, okay, and having to absorb it, or a less velocity. If I'm already moving in the same direction as the thing coming at me, my movement takes velocity off of that object. That's just a fact. I pointed out we can use a 4th example. I used the example of somebody throwing a baseball from the ground 95 miles an hour at a train moving 90 miles an hour, and I catch it. I'm only going to sense that it was 5 miles an hour. That's what it's going to feel like, 5 miles an hour. Because I took all of its velocity off of it by moving in the same direction the ball was moving. So how are any of these examples inconsistent with doing good physics or doing good reasoning? I'm providing you multiple examples of why my argument fits. And the water hose was another good one. Do you really think if the person holding the hose walks away from you, or whether you walk away from the hose, that in that circumstance somehow you're going to get hit with more or less water? Or if it's a flashlight, if he's moving towards you with the flashlight, you're going to get hit with more light than if you walk away? Well, I mean, if you walk towards. I mean, it's hard to keep the metaphor is that you're together and you move away from the flashlight, it's somehow going to get dimmer faster than if he moves away from you with the flashlight? No, it's not going to get dimmer any faster. So amazing. Alright, so you can't ever stay on topic. So he says that's not being on topic. Giving you 4 different examples of how there's a change in the energy, okay, created by the thing eating, absorbing, okay, or throwing. That if you're throwing against the tide, okay, you have to throw harder. Well, technically, if you're throwing with the tide, you have to throw harder, to be really technical. And if you're receiving, with velocity, you have to do less work. So if your velocity is in the same direction of the work you would have to do, you have to do less work. So obviously I'm on topic. Just a disgusting lie. Obviously not. Yeah, obviously to an asshole. Only a fucking idiot could sit there and say, oh yes, those aren't good examples. Because adding confusion is your motto. No. My motto is, tell the fucking truth, liars. Just like Theora Apopoulos. So my concrete examples are just like Ken Wheeler's hyperboloid wavy, it's like a coaxial cable. Light's like a coaxial cable somehow. So he's using that comparison. So it just shows how, they have no credibility. These arguments are so bad, so weak and pathetic, that this is all they got. They don't like my I gave them 4 possible metaphors, and there was something. Again, I don't think anybody with any reasoning skills could point out how they weren't relevant to the subject and didn't well illustrate the problem of some idea that it could possibly make a difference. Who's moving? Alright. Just rubbish. No. Do not save. Okay. So, that's probably enough. More than enough. We'll just check, see if there's any new comments or anything in the description box. I don't think there will be. I can talk a little bit about D. Helster. He's just such a jerk. Sorry, but he's just a jerk. So he didn't do his usual live room. I guess he's doing this. I did a Holton Arp thing. Now, I didn't hate this Holton Arp guy just because he was a little. He did point out how lensing is kind of bullshit. Okay, because he saw it wasn't there, and all these places should be. He's like, well, if this is a galaxy behind another galaxy, and this is all this light should be lensed, and it's not. So he's, he could see that their evidence was hugely inconsistent. So in a sense, we already know the Eddington experiment for solar lensing was garbage, and Arp was basically pointing out how all these galactic images are garbage. And so, yes, obviously that's one point from my side. Now, his argument against the Big Bang I didn't find very convincing. Somehow the redshift is happening at the source, which doesn't really explain the fact that there is some evidence that indicates we can tell the difference between distant objects and close objects through other mechanisms, and there seems to be this consistency. So you have to kind of use a tired light argument. He wasn't using one of those. So, I mean, it's one thing to say the expanding universe is one piece of evidence for the Big Bang. It's not all the evidence. So you kind of have to understand that in context, that just because you say the galaxies aren't moving half the speed of light, which I would agree, I don't think there's any chance they're doing that, the redshift is still real in the sense that it's an indication of how far the light had to travel. And it's the distance it had to travel that redshifted the light, because as I've pointed out, it's likely hit a bunch of atoms on the way, and each one of those atoms were more likely to be heading for it than hitting it from behind, so it hit more atoms going towards it than it hit going the same direction it was going, obviously. And so it got redshifted through a process of traveling through space. So it just takes out one piece of evidence for the Big Bang. The other one, the cosmic background radiation, never made any sense anyway. Because if there was a Big Bang, the radiation would be way ahead of the big bits. We're made out of stuff that's kind of big. That radiation would be way past us by now. We wouldn't be able to see it. So, but it doesn't really matter. I couldn't care less. Big Bang, no Big Bang, who cares? I just couldn't care less. It's not highly important as a subject, in my opinion. And as I sort of pointed out, I think the universe is just oscillating from being very compressed to being, the energy is either in the form of the trapped atoms and the matter, or it's falling apart. And I think that's what the universe is in the process of doing. It's in the falling apart stage, which means that gravity is increasing. And as the gravity increases, it will compress it again. And then it will, when all the gravity is caught inside the matter, then it'll expand again. And it just keeps doing that. Alright. I think that's enough, but yeah, he doesn't really get to, he reads sections out of the book. He never got to any real, you got to get to the details. You got to get to the experiments. You got to get to the evidence. And this whole just hype about, here's somebody saying it didn't happen. Well, that doesn't mean much when you don't get into the details of the argument. And when you get into the details of some of Holton Art's arguments, you say, well, that's not a very good argument. You know, everybody can find coincidence in the universe. So you can take two pictures out of the universe. There's smiley face galaxies. There's UFO-looking things. Now you could take those couple of pieces out of the whole universe and say, this is what the universe is made up of, UFOs and smiley faces. But we know that's not what the universe is made out of. Alright, so anyway. Enough of a video, I believe. If it recorded. If I didn't do something stupid. Yeah, let's see if I'm actually recording. Yes, looks like it I am. Alright, hopefully it's a record.